Okay, good morning, everyone. So today's live session will be on ML practices week 5, which is going to cover the Perceptron implementation in quite detail. And we are also going to go through the activity questions and practice questions. Okay, so let me start by sharing my screen. Are you able to see this Collab?
Yes, we can see. Yeah.
Okay, thank you. So this is the Collab that sir has used to that sir has used in his video lectures. So I'll go over this Collab fairly quickly and show you all the code snippets so that when you want to implement this entire application, this entire Collab on your own, you'll have a good reference on that. So sir begins by importing all the necessary APIs from sklearn, NumPy, matplotlib, and some standard libraries. There are some settings, global settings applied for all the plots. So setting the figure size to 8,6 for, if you don't provide any figure size, this is the figure size that will be used. And setting the size for X and Y labels as well as the ticks. And this code snippet is actually turning off all the warnings that you might get while training or executing code. Then we are going to load the data from the OpenML website and using the fetch OpenML API. And this is the name of the data set and the version number. And we are mentioning that return it in training set and the feature set as well as the labels in so features and label pair. Next item is we are going to convert those features and labels into NumPy arrays.
I did have a question here, sir.
Sure, please.
That seems to be not necessary because we get it as NP array anyway, and it even gave me an error saying that X did not have a method called toNumPy. So
I see. So see X and Y.
Default it seems to be. So I wasn't sure whether he was using a different thing because this time I took that other person's comment. So I've coded this entire thing on my own already. Right, and this was not needed. So
I see. So here I think sir, I'll check it offline and get back to you. If it is executed over here, I believe this sir is doing this because X and Y are in series and pandas data frame format. That's what I assume.
Yes, at least like I use this toNumPy and it works actually, because the return type will be like a series object for Y and X is data frame.
Okay, so let me just check it again because for me, the rest of the code worked without even doing this change. So let me see whether I have done some default settings somewhere else. Thank you.
Okay, sure. Now here we are exploring the data sets. How many samples are there? How many number of features are there? What is the minimum and maximum value of the feature matrix and number of classes? This data set is already very clean. I mean, it has no missing values and things like that. So all that is required is scaling of the features. This code snippet actually, just takes 9 samples from the data set and shows them on a screen. So would you like me to go through this these 2 loops, or is that okay?
So this axis, like AX, right?
Yes.
You're taking and then can you tell a little bit about this axis, guy?
Yeah, sure. So whenever you want to include multiple charts multiple figures into a single figure, you want to use this piplot subplots method. And axis, this AX is actually is an array of all those subplots. So number of rows and number of columns. So this AX will be an array of 3 by 3 because number of rows is going to be 3 and number of columns is also going to be 3. So when you want, so how would you access those the subplots? So you access those subplots with this handle AX, and you provide the indices, number of row and number of column of that particular subplot that you want to access. And then you call this image show set title and other methods.
Yeah. So what is the use of the fig variable? That doesn't seem to be used anywhere.
So yeah, that is not being used, but subplot always returns these pair.
Oh, okay, it returns this pair. Okay, figure A.
Yes, yes.
So basically, in this case, like you will get 9 axis object, right?
Exactly.
Okay. Okay.
Yes. Good observation, Ajay. Okay, so this piece of code actually just takes one of the samples and plots them. Then we go on to splitting the data. Here, if you let me enlarge it, maybe that would be better. So here, we are not doing any shuffling. This line of code only takes first 60,000 of samples in training set and rest of the samples in test set. And in this figure, we are trying to figure out if the distribution of classes is almost equal, or it's heavy on one side or on one class. And here you can observe that by looking at this figure, they are very similar. So distribution is not changing much for different classes.
Sorry, one more doubt is, why is
sure.
11? I couldn't figure out what was it. There is one extra column in the middle. There's a white column. That's what bins equal 11 seems to do. I know why. What is the need? How does it work?
So between 4 and 5.
He has put bins equal to 11, not 10, because there are exactly 10 bins.
Okay. So when we say bins, I mean how many number of boundaries do we want to have? So if there are, let's say, so all you. Okay, so how many number of divisions we want to have in total? So what happens is, let's say there are 11 bins, then there are 10 bins, then there are 11 boundaries, one which is initial, or you can count the last one as the extra one.
Okay, so that is okay. Okay, 11. Okay, I got that. Okay, so plus 1. Okay, fine.
Yes.
Now, also, like, what is that int 8? Because, like, what I saw, if I don't give that int 8, right, then all these bars will be like coming just one after another. Like there is no space between two bars.
I see. So in that case, what happens is it will take as a floating point value.
But if I use np.float, then
actually white train is actually the labels are actually characters.
They are integers, right?
No, they're characters.
Oh, right.
So they are 0, 1 in characters. So that is why it is going on. So you have to convert that to int, but I wasn't sure whether int 8 or whether even int will work. I tried with int 8, it worked, but I will try with int also.
Yeah, but if you remove that int 8, like you will see like all your bars are coming like just one after another.
There's characters, right? Probably there is a different way of handling character split bins.
So if it is taking floating point values, okay, so I think it's how the piplot interprets the integers and the floating point values. So if it is floating point values, it will assume that they are continuous.
Okay.
Yeah. Okay, so the next step is creating a binary classification estimator for 0 digit. So we are going to assign 1 plus 1, which is the positive class for all 0 samples, and minus 1 for everything else. So first of all, what we'll have to do is we have to change our training and test labels. That's the only change that we'll have to make for every place. So first of all, we are going to create the placeholders. So right now we are not assigning anything. We are creating the two new label arrays, ytrain 0 and ytest 0 of the same size as ytrain and ytest respectively, and marking them -1. That for now everything is not 0. And after that, this piece of code is looking at all the indices where 0 is present, recording into index_0 variable, and later assigning it 1. And similarly for ytest 0. I hope that is clear.
Yes, sir.
Okay, let's move on. So next thing is, after we make this change, we want to make sure that our change is actually correct. And for that, what we do is we see some of the samples. So we print ytrain, the original label vector, and we also print ytrain 0, which is the new modified vector for 0 classifier. And we can see that wherever there is 0, the corresponding label in ytrain 0 is 1. Everywhere else it is -1. So it looks okay. And we can do this checking by one more method. We can look at where 0 is present in the original label vector and the modified label vector, and you'll see that the indices are coming out to be exactly same. Okay. Next thing is, we are now going to see some of those images in this data set and see their corresponding new modified labels. And here you can also observe that everywhere which is if the sample is 0, the label is 1, and everywhere else it is -1. So
and by
for
default,
1,
it will become float, right? That np.1 has made it float.
yes, definitely, it is going to give you floats. Now, before we move on to creating a perceptron model, we are going to experiment with the baseline model. So this is going to give us a starting point. From there, we can further improve our models. So for this one, this dummy classifier API is used, and the strategy is most frequent. That means the label which has highest frequency in the data set will be used to predict for every sample in the data set. Okay, so before I move on, can you guess which sample is most frequent in our modified data set?
It will be the -1, right? So that way 90%, yeah. So -1 will be the most frequent.
Exactly, you're right. So around 10% of the samples are for 0, and for that the label is 1. For everything else, label is -1. That makes -1 the most popular or most frequent label in the data set. So that is what this base classifier, this dummy classifier, is going to predict for every sample, and that's how we are going to get the accuracy of 90%. So right, it's so dummy, I mean, that always assigns same label, but still it is getting good accuracy. And that is one reason that we don't trust classification accuracy all the time. There are more metrics to do that. So now, after creating the dummy classifier, we are going to go for perceptron model. So there is some theory part which I think you may take time and review this. I'll just directly skip to the programming part. Here, the signature of this perceptron model is being written over here, and the important things about it. Then how do we create the perceptron model? How many number of iterations we want the model to train, and what is the random state? Can anybody tell me what is the use of this random state over here?
Just to reproduce the result every time.
Continuously. But I wasn't sure why 1729, that funny number. I mean, of course, Ramanujan's number is being used.
So I think we loved that number in Ramanujan sir also. That's why we put it there. So, sorry, for you could put anything else also. And rest, Rajiv. That is for reproducibility reason. Let's move on. So now, here we are fitting that model, the perceptron model. And after fitting the model, we are printing its coefficient matrix, shape of the coefficient matrix, and the intercept. So intercept is going to be the bias term. So it's a scalar. That's why we are seeing only one value. For the coefficient matrix, we are going to have a matrix of, I mean, 1 by 784. 784 is the number of features in this data set. Next thing is this code snippet calculates the accuracy, and you can see that the accuracy is 99%, pretty well. Test accuracy comes out to be 98%. Now let's look at some of the predictions visually.
So sir, these scores are R2 scores, right? Or it's different?
This one?
Yeah.
I think this should be precision.
This will be precision, okay.
Yes. And let's move on.
Yeah, sir, but why call it accuracy, sir? That's why I was confused with the thing.
Correct.
The score, because we keep saying accuracy is not a good score. So
yeah, we'll come to that, sir. We'll come to that. So just hold on. So bear with me for a few minutes. That all the classification metrics like recall, precision, and FN score, they are going to come next. Now what we are doing is we are displaying the predictions. I mean, now we are visually inspecting the predictions. So what is being done by our classifier? So you can see some of the samples where, for example, if you look at the second row, first column, you'll find this 0 over here. And so it is predicted as 1, which is positive class, which is our 0. And everywhere else, it is predicted -1. So these are correctly classified samples. Okay. And these are some of the samples where all of them are 0 and they are predicted positive. Now we are coming to the different evaluation matrix that for classification. So this is the overall confusion matrix for this model. Okay, before we move on, would anybody like to tell me how many numbers of samples are not correctly classified? How would I see that?
122 plus 421.
Exactly, sir. That is the right one. Now we compute precision and recall. Okay, so for this particular model, everything turns out to be, I mean, nice numbers. See, sorry, I'll take my word back. For this one, the accuracy score is being calculated by this formula and not by precision. It's different.
Means originally the score just gave the accuracy. That's why I was kind of confused. Why does the score by default give accuracy? Remember
Yes,
the
yes. Yeah.
It seemed to be kind of counterintuitive, no? So it should give at least precision or recall.
Right. So I mean, there are right now we have 4 metrics: precision, recall, accuracy, and FN score. So by default, it gives you the accuracy only. If you want to look at the other matrix, we will have to use classification report or confusion matrix. Okay, now let's go to the next step, which is the cross validation. So here we are using that binary classifier, perceptron classifier, giving them the training set using 5 as the cross validation folds. And we are going to use 3 scorings: precision, recall, and F1 score. And now here you will see that after doing the cross validation, you'll find that there are 5 different models, because there were 5 cross validation folds. So cross validation train the model 5 times. You'll see fit time, score time, test F1 score, test precision score, and test recall score for all 5 executions. After that, the aggregated F1 score, precision score, and recall score with their standard deviations. Then comes our okay, give me one moment. This is okay. So these are the results on test data by the first estimator that we get from cross-validation testing. Next, we compute precision and recall. Now, okay, so this one. All right, so okay, got it. So this one, what we are doing is we are creating the confusion matrix from the predictions of the cross validation procedure. Next, computing precision, recall, accuracy, and F1 scores. Then looking at the classification report.
So this cross-validate predict, like that you are retrieving from the cross-validation, from that cross-validation stuff, right? And that
Exactly.
time you are using that validation data to find out cross-validate predict, right?
Validation.
Yeah, because
Pardon
in
me.
that
Can you?
yeah, like when you have given this CV equal to 5, right?
Mhm.
So that means 4 was used for training and 1 was used for validation, right?
Exactly.
So you are using that predict method on that validation data and find out what is the confusion matrix.
No. See, are you talking about this confusion matrix or the
Yes,
previous
yes,
one?
yes. Like
This.
I'm trying to understand what is the difference between cross-val score and cross validation, cross underscore validation and cross underscore val underscore predict.
Okay, so this one is actually see. Okay, I get your point. So cross well predict actually moves one step forward and does the predictions also after doing the cross validation.
But you are passing only X trend and Y trend 0, right? So that means it has not yet seen the test data. So whenever you
Right.
will be predicting, that means in that CV5, CV equal to 5 means 4 folds you have used for training that estimator, and 1 fold you are using for predicting that using that validation, right?
Yes.
So this
Yeah. So
cross-val predict will use that validation
As a test set.
scores.
Right, Ajit.
Okay.
the idea, I guess, is that you will take the best model from cross-val predict and then use it for further prediction of the test.
Yes.
Okay.
Okay, now the next thing that is covered in this collab is the precision versus recall trade-off. Okay. So can anybody tell me what this chart represents? Okay, so this time we are not just using the same, we are using the trained classifier, but this time we are not just making the predictions. We want to compute the scores of those predictions also. So decision function, if we pass the X train, it is going to give a score for every sample in the training set, and those scores will could be for and that could range from negative values to positive values. And the positive values for any sample, the score is positive, that means it is belongs to positive class, and if it is negative, that means it belongs to negative class. And you will see that this is the distribution we get. Okay, so there's this nice question. Why? So if you look at this graph, you will see that it is right skewed distribution, and you will see that very less number of samples are there on 0 or so very less number of samples have scores 0 or more, and there are many samples which have scores lesser than 0. Can anybody try to guess why is that so?
Yeah, actually there are 10% only positive sample, right, and 90% negative samples.
Exactly. That's why we are getting this imbalanced distribution.
Can you please explain the reason again?
Sure. So see, in the data set, in the modified data set, the number of zeros are 10%, and every 90% are non-zero numbers. So 10% of the classes, 10% of the samples have label 1, 90% of the labels have -1. So how do we decide these labels? So any sample who gets a positive score, okay, gets a positive label. Sure. Now let's move forward. Now we are going to chart the precision and recall curve. Can anybody tell me how is this calculated?
Like the formula for precision and recall?
No. How this curve is calculated? Okay, so keep this question in mind. We are going to answer them in the activity. Answer this question in activity questions. Okay.
So actually, you are not audible. What did you ask?
So my question is, how do we create this curve? How do we compute it?
So basically, like when you finally say, for example, you get a trained estimators, right, and from there, like if I calculate the precision and what is the recall, and then if we plot this.
Okay.
No, but in that case, you will get only one value, right?
Exactly.
Yeah, that's what.
So we are doing it for multiple samples, like shuffle. Sorry.
No. Shuffling is not the right answer. So keep this question in mind. We are going to come to that. And okay, I think this should give away the answer. So in this chart, we are taking a look at the precision and recall curves by changing the thresholds. Okay, so if 0 is the threshold, this is we are going to get what precision recall do we get? The precision recall we get by putting threshold 0 is the same values we have computed earlier using confusion matrix. Because by default, for Perceptron, the threshold is 0. if you want, however, if you want to create these curves, we have to change the threshold and then compute the number of we compute precision recall, and then we plot this curve.
No, sir, can you come again, please?
See, what is the x-axis?
Threshold.
Right. And look at this chart. What is the x-axis?
This is number of negative and positive in the summation.
What is the x-axis? Yeah, you are right. The numbers of
Yeah, from 0 to 400 is positive, and this side it is a negative plus.
Yeah, so x-axis is represents the score and y-axis represents the density or frequency, right?
Yes.
Yes. Okay. So what happens if I put the threshold as 0? Then all the numbers. How many samples will you classified as positive? Just mark a perpendicular line at 0 and count everything which is at right. Agree?
Correct.
Yes, correct.
But what happens if I change the threshold?
Okay. So based on the value will change the.
Exactly. So my positive and negatively predicted samples will change, and that's why precision recall will also change.
Okay.
Now this is the classification report. The next curve that we plot is the ROC curve. So this is on the x-axis we get false positive rate. On the y-axis we get true positive rate. Any idea how?
I'm so sorry. Were you asking what that curve represent? Like, were you asking that is a PR curve?
No. What I'm asking was how to create this.
Not
curve.
this one, the above one.
This one, yeah.
Is it you wanted to say that you wanted to hear that it's PR AUC curve?
This is PR curve, not AUC curve.
PR and
ROC.
the area under the curve represents. I forgot. Yeah, but yeah, I got. Was that your answer? Like, what question?
My question was how to construct this chart.
Okay, construction.
Yes.
Okay.
Okay, and I think you should be able to guess it now, how to construct this chart also.
Sir, one question. Precision and recall can understood that because you have a true positive, and one case you are taking the precision, one case we are taking okay. But when we are taking this false positive and false negative, what we are actually achieving? Because in both cases, the prediction is either false, or in case the actual was true and the prediction is false. So what we are achieving from this graph, that I'm not getting.
So you are talking about this chart or the previous one?
No, this chart, this ROC. This false positive and true positive. Yeah.
Okay. So false positive rate. So first of all, so before you proceed, can you tell me how would you compute false positive rate?
False positive is going to be your if actual is minus and your prediction is positive, -1 and actual is 1.
Okay. So what happens if it? This chart actually represents the area under the curve for whichever. So we could have multiple models. So right now we have only one model, and we don't have anything else to compare with. We have this base estimator. Okay, so the curves. The curves for a model, if it has high area under the curve, it is supposed to be better. And the curves which for example, this base estimator, and the area under the curve is not more than the blue curve, therefore it is worse than the our perceptron model. So that's it. That is what we want to capture.
Okay, understood.
So let's say if we have 10 or 20 classifiers and they are giving us results, some of them are good on precision, some of them are good on recall, and still we want to compare them holistically, we can use this method.
Thank you, understood.
Okay.
So here you are comparing number of different estimators, and that's why you are plotting this.
Number of different estimators?
No, like as you said, like say even like for this curve, okay, you get like when a estimator is trained, like you will get a single false positive rate and single true positive rate, right?
Exactly.
Then yes. So now like how the like this continue, because that is now a point.
Yeah. So same question is how to construct this chart, right?
Correct. Same question, yes.
Yeah. So that is being answered from this. Similarly, you can take an answer from this graph.
Okay, that means you will be changing the like thresholds and calculating like, okay, how the like this precision recall stuff is coming, and corresponding you will be plotting that. Is that the understanding?
You disconnected.
Hello, can you hear me?
Yes, now.
Yes.
Sorry, I think there was some network issue. Give me 1 moment. I'll share my screen. Okay, is my screen visible?
Yes.
Okay. So Rajiv, I think the answer to the question how to construct this chart is same as that of how to construct this chart. Okay.
Okay, sir.
Okay. Can anybody tell me what is warm start and cold start?
Yeah, warm start means like in case of like if we want to use do not want to use weights to be initialized to 0 every time we run. So, and warm start equal to like true means like it will take the previous w whatever it has calculated, and from there it will start the calculation.
Right. Okay, now we are at the position that where we can start thinking about multi-class classifier problem. So as of now, we have converted our MNIC dataset into binary class classification problem by taking 0 as positive class and everything else as negative class. However, that is not the case in real world situations, and even in this data set also. Now we are going to take on a full-fledged multi-class classification problem. So how are we going to extend our binary classifier into multi-class classifier? We are going to see that. Before we do that, we have to first do label encoding for our label vector. So right now it has 10 values, but we have to convert those into one hot encoding, something like this. And now this new label matrix is termed as Y train OVR. OVR stands for one versus rest. So one good thing about Perceptron is that we don't have to worry about I mean, externally, we don't have to worry about how to take care of multiple classes. It takes care of that internally. So I'm going to go quickly over that. Okay, now here we are training our model. Then after we train the model, let's look at the coefficient matrix as well as the intercept. And you'll find that its shape are, the shape of those two are 10 by 784. So 10 stands for number of classes. So for every class, it has trained a classifier, 1 versus rest, just like we did for 0. And the bias also has a shape of 10, 1. That means for every classifier, we have a bias term. So 10 classifier, that means 10 bias terms. And here we can also, so how does it then makes a single prediction? It actually, so for any new sample, it predicts the score for every class, and whichever class gets the highest score is the predicted class for that sample. Now here you can see for one sample, we are computing the scores for every classifier which is trained internally, and you will see that there are 10 set of scores. The highest value is 154, which belongs to second index, and therefore the predicted class is 1. Again, the classification report. This time the confusion matrix has 10 rows and 10 columns. Each column and each row representing a label. Now this entire process can be put into a pipeline. This way, things you can write very concise code. Min-max scalar and then applying the perceptron. So it has only 2 steps, no cleaning or imputation steps. And this is how you can make the prediction and get the confusion matrix also. Next item is we are going to compute the or plot the learning curve, which is iteration versus loss curve, using with the help of partial fit. So partial fit method is going to be used for this particular case.
So this partial fit means like you will not do that final thresholding operation, right?
No. It will do the final thresholding operation also. So fit. No, we are not talking about prediction. We are talking about fitting or training.
Yeah, correct. Like say for example, in case of a say for example, if I take the fit, right? Fit in case of a linear regression, what we do like fit is like XW, right? And now in case of a classification fit, like you do a XW and then you do a NP where, right? NP where like if this is within that threshold, then you will say either 1 or -1, correct? So what is the difference between this fit and partial fit?
Okay. So I think partial fit, give me one moment. It does not run the, I see. So I think it runs only one iteration.
Because in case of a MLT, right? So that time I saw like sir has written one class where he has implemented fit and partial fit. And fit is simply like partial fit is kind of giving you that XW. Okay.
Sorry, I'm not getting what is XW.
XW means like your W transpose X model. Okay, your model is
J
W
into Z.
transpose X, right?
W transpose
Means W1 W0 X0 plus W1 X1 plus W2
yes.
X2. That is
Okay.
that will give you the partial fit. But in case of a classification, the fit will do after that you get the result from partial fit, right? Then you will do like whether this is greater than a threshold or not. If greater than threshold, say for example for this perceptron, right? If it is greater than 0, you will return 1, otherwise -1. So that particular code will be there in fit, but not in partial fit.
See, when you're talking about assigning +1 and -1, that is prediction, right?
No, even for like that is yes, like that is for prediction, that is correct. But even for fitting the data, right? Because when you fit the data, you'll have to get okay how much
Loss.
loss, right? Right.
Okay.
So to calculate that loss, you need to predict even in the fit also internally.
Yeah, for that is going to happen for partial fit also.
In that case, the question is like, what is the difference between fit and partial fit?
Yeah, good
May
question.
I?
Sure.
So partial fit actually works on only one epoch, like one iteration, pura. And whereas this fit goes for multiple epochs. Also, once you fit the data is completely transformed, and if you call fit again, then it will be transformed on the new data set. Whereas it's not the same case for partial fit. So I think one of the classification between these two is this. I guess if I'm not wrong.
Yeah, yeah. So, Rajiv, the only difference between those two are number of iterations for which they run. Partial fit runs only for one iteration, and fit runs for the number of iteration mentioned in the class declaration.
Okay, like what I'll do probably like I'll post this question in the Discord forum with like that MLT stuff. I'll paste it. Okay, because like I have confusion from there, because in that the fit method first calls the partial fit and then it does a NP where. Okay, I'll post the paste that code so that we can discuss on that, because I have certain confusions over there.
Okay, sure.
Yeah, yeah. Okay.
Then the learning curve is okay. So using this partial fit, the learning curve is plotted. So again, for plotting the learning curve, you need to have the loss, training loss, with every iteration. So what are the values? Is it increasing? Is it decreasing? So that is only going to happen if we can train the model iteration by iteration, and that is achieved by partial fit. And this is what you get. Okay, now we can implement grid search with this model. And there's only one parameter with which we can experiment. There's only one hyperparameter for Perceptron model, which is its learning rate. And this is the result that you're going to get for cross-validating the Perceptron model. Okay, and this particular chart represents the similar learning curve, but for two different learning rates. One learning rate is 1.0, the other learning rate is 0.125. And you can find that the training loss is actually low for learning rate 0.125. And we can get the best estimator from cross validation using dot best estimator attribute. And the last thing that we are going to say is so now we have this weight vector for a particular class or all the classes for multi-class setup. What actually it looks like? What does it do internally? So now you will see that some of the misclassified samples. So if you look at the second column, third row, which is actually 5, it looks like 5. I don't know what the actual level is in the data set, but it is predicted as 1, and its ground truth is -1. That means it does not belong to 0 class, but it has been since it looks 0, there is a circular shape at the bottom. I mean, because of that, maybe it classified it as 0. Then these misclassifications are happening. this triggers us to think what actually our model is doing. I mean, what is the weight vector? What is the visualization of that weight vector? And this is how it looks like. So this is our weight matrix for, I think, 0.
Okay, so you are getting a weight matrix of like 10 by 784. So you are taking one and reshaping it to 28 by 28, and then you are plotting it, right?
No, this represents only one of those, not all of them.
Yes. Like say for example, you got 10 by 784 weight vectors, right? That weight matrix.
For multi-class classification problem, yes.
Yes, and then say for example, if I take the first one, that is it will be of 1 cross 784. That means you'll have to reshape to 28.
So this belongs to the 0, Rajiv. This belongs to the 0 class classification object. See,
Understood.
so I'm taking only the coefficient of it, reshaping it to 28 by 20. If I had taken that for multi-class setup, this W would not be 1 cross 784 matrix. It would be 10 cross 784 matrix. Then it would not have been possible to do this.
No, but in that case also, say for example, 10 cross 784, right?
Mm-hmm.
Now, if you take that W, say for example, W subscript 1, okay, that means
Okay.
you will get 1 by 784, right?
Yes.
And then that 1 by 784, you can reshape it to 2820, and then you will see like, okay, W1 means probably how 0 is learning, or if I want to see how 5 was learned. So
Yes.
W4, 78, W4.
Yes, absolutely.
Okay, understood.
Yeah. So this is how the weight matrix looks like. The wherever there are white, lighter spots, white spots, you will see that the values of that those particular pixels are high, and wherever there is black or dark spots, the weight parameter for those pixels are small or low. Now this is how it looks like on if you apply that on a particular image. This is how it will activate. So you can see that exactly where there are whites, you will see some I mean anything other than gray, and the black spots from the images are converted into gray spots.
Yeah, this is a nice way of like understanding this model. Probably even say for example, if we occlude some of the pixels from the original image and see like how this is coming, then probably we can understand, okay, what all what all pixels are contributing more to this.
Exactly.
Yeah, that is an interesting way.
Then activation visualization for digit 5, and I think that's all of it. Any questions so far? I'm pretty sure you will have more questions. Please feel free to post them on Discourse also.
Yes. Mostly on that ROC curve and those curve actually. But we'll post and
So I would suggest that try to create those on your own and see
correct.
what results you get. Okay.
Yes. And probably like we can spend some time, like if possible on Friday, to discuss more on that, because I couldn't complete the entire week 5 yet.
Okay.
Yeah.
So one announcement I hope that must have made to you, that the Friday session will be a revision session.
Oh, okay. Friday session.
So week 5 solve with instructor session will happen next week, not this week.
Okay, perfect.
All right. Now let's go to our activity questions. Is my screen visible?
Yes, sir.
Okay. So the first question is, what is what is the variant of ridge classifier? Sorry. What is the original regressor from which ridge classifier is actually derived?
Yeah, ridge regressor.
Ridge regressor. Right. The first step to apply ridge classifier should be
Set alpha.
you sure about that?
No, first we need to initiate the object now. Then only you can pass.
Yes, I agree with that. First of all, before we, of course, set alpha is good. Yeah, instantiate the classification object, and then we can pass different parameters. Which of the following solvers uses SciP linear algebra solve function to obtain a closed form solution of the minimizing the cost function? I think this is something which is mentioned in video
in the lecture. Yeah.
Can anybody tell me which one is that?
Yeah, it's a Cholesky. But this type of question will come in the in-term exam because it's very difficult to remember all this.
Yeah, I agree with you. So they can come, yes.
So we need to start listening. Okay.
So some of the things, these things are worth keeping in mind when you're solving real problems.
Yeah, like SBD, list square, these are, but these Chomsky we have not used. Maybe after some time we will get familiar. Maybe SBD.
Yes.
These are familiar now.
Sure. Question number 4. For large scale data, which solver can be used in ridge classifier?
Sparse CFG.
Yeah, I think the name gives it away.
Yeah, that's it.
Question number 5. To choose the solver automatically based on the type of data, which one can we use?
Yeah, second one, solver auto.
Exactly. How do we make predictions on data samples? Using predict method, using densify method, using classify method? Predict method.
Yeah.
Mention true or false. Logistic regression is a linear model for classification rather than regression.
Yes, linear model. True.
Which of the following codes can be used to set regularization using penalty in logistic regression classifier?
Yeah, the first one.
Okay, the first one assigns L2. The second and third, they are setting the solver parameter, not the penalty. And the last one is telling 0.12, but not the type of penalty. So only the first one is correct.
Correct.
Question number 9. Which of the following solvers is used for logistic regression classifier applying on a small data set?
And then linear.
Linear.
Right. In logistic regression classifier, all the solvers support all the penalties. True or false?
No. Yeah, false.
Yes. Which of the following statements are true about SGD? It is an efficient approach to fit linear classifiers under convex loss functions.
Yes, true.
This seems true. It is an optimization procedure.
This is true about SGD, stochastic gradient descent. Yes, this is also true actually.
It corresponds to a specific family of machine learning models.
Specific family of machine learning models.
Or it can be used for regression, classification, anywhere it can be used.
Right. But is it a model?
No,
Actually,
no. Like this is a like a method. Stochastic gradient descent is an approach, but not a model.
Right. So the third option is not correct. Question number 12. What does SGD classifier implement? A plain stochastic gradient descent learning routine, a plain stochastic gradient descent ascent learning routine. Third is classification based learning routine. Fourth is ridge regression based learning routine.
The first one.
The first one.
The disadvantages of SGD classifiers include efficiency, ease of implementation, requires a number of hyperparameters, sensitive to feature scaling.
Yeah, like third one, like fourth one, third one.
Yeah, first two look like, efficiency and ease of implementations are like advantages. So they are definitely out of
Yes.
place.
Third and fourth.
Third, requires number of hyperparameters and sensitive to feature scaling, right?
Feature scaling, yes.
Which loss functions are supported by SGD classifier?
Huber loss, modified Huber, and hinge loss also probably.
Okay, anything else? So there are two hinge losses.
Squared. What is hinge loss actually? Is it like squared error loss or what?
No, it's not a squared error.
So what is that hinge loss actually? Can you give a little bit explanation?
So hinge loss, perceptron loss. Did you look at one of the slides in the videos?
Yes, yes.
So it looks like, give me one moment, I think. So for, X for threshold, let's say 0 is our threshold. For below 0, it's actually, it follows the curve X is equal to minus Y or Y is equal to minus X. And for threshold greater than 0 or equal to 0, it is flat, Y is equal to 0. That is your hinge loss.
Okay.
So I think it supports all. Anybody else?
You can pass the perceptron also in SGD classifier. It's also a loss.
Right.
Maybe the hinge loss.
It actually supports both of them.
Oh, okay.
How to specify maximum number of epochs in SGD classifier?
Max iter.
So there are two max iters.
The second one.
Second one. Okay. Okay, all our answers are correct. Let's move to second set of activity questions. Mention true or false. Perceptron classification shares the same underlying implementation with SGD classifier. True or false?
True.
True.
It's true. Right. It's true.
Correct. Question number 2. Partial fit method is a way to plot iteration versus loss curve.
Yes, true.
That's also true. Give me one more.
Yeah, sure.
I'll be right back. Okay, so let's move on to the next question. Question number 3. Okay, so for question number 3 and 5, refer to following diagram. I think this is the same chart that we saw a few minutes back in the Collab.
Yes.
So on x-axis we have iteration, and the y-axis we have training loss. And the blue curve represents learning rate to 1, and the orange curve represents learning rate to be 0.125. Okay. the general trend of variation in training loss with number of iteration is? So training losses increase exponentially with number of iterations. That is not entirely true. That is wrong. Option number 2, for eta 0 equal to 1 and eta 0 equal to 0.125, the mean of the training loss remains within a particular range of training loss with change in iteration. Okay, so what is happening? What this statement means is, for each learning rate, the mean of this training loss is going to stay in certain range. That means it is neither going very high or too low. So this seems okay as of now. Let's go to option number 3. Eta 0 is equal to 1. The training loss decreases with number of iterations. And for eta 0.125, the training loss increases with number of iterations. So that is definitely not true.
Yeah. That is false.
Option number 4, the training loss increases with the number of iteration.
This is also false actually.
This is also false. So
because they are more or less constant.
Yes.
The second option is okay.
Sir, why is the fourth option wrong? Just can you repeat?
Sure. See, for it says training loss increases with number of iterations for eta 0 equal to 1.
Can you go to the graph one?
Yeah, actually, if you see the curve, like they are more or less constant, like oscillating in around the same mean.
Yeah. Okay, got it.
So that is the reason, like any increase or decrease, like made it wrong.
Okay, so both are constant within their ranges, right?
Correct. More or less, the mean of that error is constant. Yes.
Okay, got it. Thank you so much.
No problem.
Hello.
Yes, sir.
Sorry, I think there was another network issue. So where was I? I think the question was why fourth option is wrong. Hello.
Yes, sir.
Yeah. So the fourth option is wrong because the training loss, it says for eta 0 is equal to 1, the training loss increases with number of iterations. And that is not true. It is going down and going up. So it is kind of fluctuating.
Oscillating.
Between around 0.4 to there were some peaks at 70th iteration or so. So between 1 to 0.3, it is fluctuating. So this option is therefore false.
So the second option is right.
Second option is correct. The mean value, question number 4, the mean value of training loss for eta 0, 0.125 is in the range. It's less than 0.1. So what is the range of our loss?
Yeah, I think less than 0.1.
Less than 0.1.
Less than 0.1. Okay. For what value of eta 0, the graph of training loss is noisy?
1.
It is noisy for both, but it is noisier for 1.
1.
Question number 6. Mention true or false. Grid search CV conducts exhaustive search over specified parameter values for an estimator. True or false?
Actually, like there was a discussion and it seems it is true, but I had different views actually.
Okay,
say for example, in grid search CV, we can give parameter like discrete parameters, right? Say for example, when we do our polynomial stuff, right? We can say, okay, like polynomial features, you can give degree 2, 3, 4, something like that. So it will go and search only those parameters, discrete parameters.
Right.
But in case of a randomized search CV, you can give a kind of np.log space or like a uniform, okay, and it will do a exhaustive search in that space.
See, np.randomize, the randomized search actually leaves out some of the candidate samples. It does not do the exhaustive search. Am I right?
No, that parameter space where you need to search, right? That is kind of a continuous for randomized search and discrete for grid search.
Okay. So, Rajiv, I'll have to get back to you on this one.
Yes. But actually, like after that, Jimmy also posted, and I saw the lecture video also. There also they write exhaustively search. So the option should be true actually. Yeah, according to that. But yes, if you can, like, there is a question like a discourse forum. If you can also post that, because my point of view is like then if I have that same stuff randomized search CV here, my answer yes or no. Or if I give two things like grid search CV and randomized search CV, okay, who will be doing exhaustive search?
Okay. So
So
one thing I can tell you is that the grid search CV takes all possible candidates from the parameter grid and then does the searching and find out the best model. Randomized search CV is actually takes random samples. It does not take all of those. Hello.
okay, because in the lecture, like Sat told, you can give a continuous space search space in randomized search CV.
Okay, Rajiv. So I'll
No problem.
take a look.
Problem. Yes.
Take a detailed look and we'll come back to you.
Sure.
Okay. The next question is single label multi-class classification have how many output labels? So
One.
I think it wants to ask in the data set how many output labels are there if the problem is single label multi-class classification. Yeah, so answer should be 1. Yes, it actually gives away, but it is given away by this one, single label. Question number 8, mention true or false. One versus rest classifier supports multi-label classification or not?
Yes.
It does.
Yeah.
Okay, let's check the answers. So we are getting wrong for this question only. Okay, I'll take a look into this. All right. Let's go to next set of activity questions. Which stratified APIs are provided by sklearn model selection module to create folds?
What is the which standard API model selection create folds certified repeated
Is it one is repeated and other one is stratified?
stratified, yeah.
What
Even
about
like stratified is a shuffle
three,
split
yeah.
also, right?
Yeah, all three. First three.
All three.
Right. Question number 2.
Can you mention OVR?
One versus rest. So it's not an API at all.
Okay. Actually, I haven't seen the lecture 3 onward, so I don't know.
Okay. Question number 2, mention true or false. Confusion matrix evaluates classification accuracy by computing the confusion matrix with each row corresponding to the true class.
This is true, I think.
Yeah, it's true because they are comparing one by one, then they are counting it. True positive, true negative, and all.
Right. Question number 3, confusion matrix can be displayed with which of the following sklearn API?
Yeah, confusion matrix display, first one.
Right. We just saw an example of that.
Yes.
Question number 4. Which which NB is used to implement the Gaussian Nye-based algorithm for classification?
So what is which NB? Gaussian NB.
Yes, Gaussian NB. I think the name gives it away. It should be Gaussian NB, yes. Okay, all our answers are right. Let's move forward. The data matrix of the label vectors given as pandas data frame can be converted to NumPy array by which of the following methods?
Two NumPy. Two underscore num. The first one. Yes.
The first one.
Question number 2. What is the number of samples in MNIST datasets? Dataset.
70,000.
70,000.
70,000, right. Question number 3. Which of the following functions is used to ensure the used scikit version is at least 0.20?
Underscore version actually.
That is right. So
First
it is
one,
being
first
used
one.
First one.
three
First
times.
one.
The first one, greater than equal
It's at
to
least,
that.
no?
Yeah, at least, right.
Yes.
Question number 4. How many features are present in MNIST dataset?
That's 784, 20 into 28.
Yeah, 780.
No,
That
86
is
not.
right.
84.
784, right.
Yeah,
780.
784.
Which of the what is the maximum and minimum value of features in entire MNIST data matrix?
It's 0 and 255. That is the color.
That is right. That is right.
Yes,
So
yes,
there are
yes. 0 and 2.
256 levels of color, and that is the range. Question number 6. The function. I think there is some misprint in question number 5. The function gz defined as.
Signum function.
For now, let's. I cannot understand it. Can you understand it?
Like what it is asking, like that sign function, right? Like whether it will give -1 and +1. So that is your signum function, right?
Okay, you guess it from there.
Yeah.
Okay, for now I'm going to leave this. We have to get this formatting correct. For question number 7 to 11, refer to this figure. Okay. Question number 7, the true positive elements in the confusion matrix is true positive. That means they are predicted positive and they are
The yellow one.
true positive.
Yellow is negative. That's this one.
Yellow is negative.
Yeah.
Okay, -1.
-5,581 or 5. What is this? 5,581?
Yeah, that one. Where the
5,581. Right. Question number 8, the number of false negative elements in the confusion matrix is false negative. That means they are positive, but they are predicted negative. Let me enlarge it so that it is better visible. False negative.
Yeah, this 542, right? Or
342.
342. Yes.
342. Yeah, I left bottom corner, right?
Yes, left bottom corner, right?
Okay, that's right. So 342 is the right answer. Question number 9. What is precision value? For this, you will have to help me.
Okay.
That is TP by TP plus FP, bro.
We need to calculate.
Yeah, that we need to calculate.
Okay, so this is the precision side, not predicted. Okay. Five eight one plus divided by 5581 plus 342. What is it? This one. It's predicted. No. It will come 336.
0.942, but the option is not there.
Then I'll go with 0.946. Let's see. What is the recall value? And I think F1 score accuracy is also coming up. What is the recall value? Okay, take some time and compute recall. 943. 943, you're saying?
Yes, it is true positive divided by true positive plus false negative, right?
True positive divided. Yes, yes. False negative.
So it is 5581 divided by 5581 plus 336.
So 5581 divided by 5581
plus 336.
No. It will be this.
342. Okay.
342.
Yeah, that is, I think, precision. No?
So predicted label is 1 divided by true positives plus false negatives.
Okay, so false negative is 342. Okay.
Yes.
Yes.
And compute this recall value. After recall value, compute the accuracy also. I think that's the only question requires after these two sum calculations. Okay, so what is the value of accuracy and what is the value of recall coming out to be?
Accuracy is coming for 99.
Accuracy is coming out 99. Okay.
The accuracy is also 0.99.
And what is recall is also coming 99.
It's not 99 actually.
It should be 0.96.
Yeah, 96. Yes.
Okay. Okay, let's check the answers now in a minute. What is the formula for calculating recall?
recall is EP upon TP plus FN first.
First one, right? The formula for calculating F1 score.
2 in the numerator. So
Second one.
my plus sign. So second option.
Second option.
Second option.
Question number 14, the precision recall curve plots. So this is the question that I was referring to earlier. Precision recall curve plots a graph with precision value on x-axis and recall value on y-axis, computes precision recall pairs for different probability thresholds, computes precision recall pairs for one singular probability threshold, plots graph with recall value on x-axis and precision value on y-axis.
Second option.
It does
Second
for
option.
different probability thresholds, right?
Pardon me?
It's option B, right?
Option B, yes. I think more than one answers, if there would have been possible, one of the option A or D should also be true.
So you can change the axis. I mean, X and Y, you can switch them, right?
We can do that, but typically we don't do it. Because, you know, the area under the curve, the definition of area under the curve will be changed, right?
Okay, okay. Yes.
Okay, let's check our answers. Okay, two of them are wrong. Let's see which two. So correct answer is 336, 342. Okay, what did it ask? False negatives.
False negative.
So we have
Predicted
labeled them as
negatives,
negatives.
and it should be true. So I think 342 is the only thing, right?
I'm also thinking same. So we are labeling it as negative, but they are not negative. They are positive.
Yes.
So yeah, 342. I think our answer is correct, but in question it is configured incorrectly. And which other question we are getting incorrect? Okay, this one we left. All right.
And the other answers also, they don't match actually. The 9.96 and 9.4, it is something like that is coming. This 9.6 is not 9.6, it is something like 9.4 or something. So the correct option is not present here.
Okay, okay. So please post this in discourse. We'll take a look at this.
Okay.
All right, let's move on to the next set of activity questions. Mention true or false. Combining multiple binary classifiers and devising a suitable scoring metric are used to extend the idea of Perceptron to handle multi-class problems. Is it true or false?
True.
Yes, it is true. Question number 2. Perceptron is a part of which of the following libraries?
Linear model.
Linear model.
Yes. Matrix have evaluation matrix. Pre-processing have scalars and one-out encoders and other things. Only linear model has perceptron. Question number 3. The class of perceptron that outputs the maximum score for the input sample is considered as accumulated, regressive, predicted, or none of these.
Predicted class.
Predicted class, right. Question number 4. Mention true or false. Grid search CV can be used to improve the learning rate of the perceptron model. True or false?
Yeah, we can do multiple folds, right? Then it will be true.
Yeah, I also think it should be true. Let's see. Okay, all our answers are correct. So I think we are done. Do you have further questions? Okay, great. So let me stop sharing.
Sir, can you take that practice assignment?
Okay, let's go there. My screen visible?
Yes.
Okay. So the load MNIC data set, and how many number of samples are there in the data set? I think we have answered this in one of the activity questions.
70,000.
70,000.
Yes.
Sir,
Access
in this,
this.
I wanted to ask just for the first question. Here, I mean, it says we have to open that MNIST 784 version 1. Why is this necessary? I mean, for the other data sets like California housing and all, we didn't need anything like this. So how is this data set different from those?
See, so good question. Some of the data sets come bundled with sklearn library.
Okay.
Okay. The other data sets, even though they are standard and quite popular, they are not bundled inside sklearn library. So sklearn provides a method to access those convenient methods. So you don't have to go to the website, download the CSV file, then upload into your Collab or in your workspace. What you can do is all you have to do is call this OpenFetch API and provide the name of the data set and the version of the data set. That's all you have to do.
Okay,
so do you know where this?
How do we know these version names? I mean, it is given here, that's all right. But if we want to fetch the data for practice and all, so how do we know these names like MNIST 784 and all?
Okay, so I'm going to, do you know where is this coming from? Where it is downloading from?
So we fetch that as fetch underscore MNIST OpenML, right?
Exactly. It is coming from OpenML website.
It's a website from where you need to pull it.
Okay.
Exactly. OpenML,
yeah.
There it is. So it is coming from there. So this site has this site is actually a repository of hundreds to thousands of data sets. It is coming from there.
Okay.
Okay. Does it answer your question?
Okay, but I just wanted to know in Collab itself, like, can we get some information about like which if I'm opening this for the first time, let's say, and I don't know where I have to pass this 784. So how will I come to know that I have to pass this thing if I'm using only working in Collab?
If you are working in the Collab, okay. So before you start working in Collab, you must know what data set you are working on, right?
Okay.
Do you agree?
Yes.
Yes. So either you have a CSV file or some other source, or you have this.
Yes.
And if you like to, the reason I opened this website is if you want to explore the data sets, the types of data sets, small to large, you can take a look at these.
Okay. So the thing, the difference in this and the other data sets like California housing, we get the entire data in just one call.
Even in this, you get the entire data in one call, but this is being downloaded from internet.
Okay, so it is not bundled with sklearn.
Yes.
Oh, even California is not bundled. When you are calling California, it is going to the particular site and pulling the data. Okay.
Right.
But you don't have to pass any additional parameters, right?
Yeah,
like
you don't need to
pass.
Yes. So they given one small API which is automatically pulling. But for putting OpenML, you should know what data, which sir told, which data, which version. Because this MNIST 784, they can come with another version called MNIST 800. If you want 800, you need to pull it because second data every time. It's already preloaded. That's the reason. Okay,
so we just have to be specific about the data that we are using.
Yeah, even we have to specify the version, which version.
Okay, yes.
That is more important. If you're working in old data and somebody is updated, then your entire program will crash. Okay, that's why you need to put the version also.
Okay.
Yeah, thank you, Mukesh, for correcting me. Actually, loading California housing data set also spans a new connection over internet. So data is downloaded from internet, not so that that particular function or API load California housing. That one is standardized. It is not so we don't download California housing data set with OpenML. Fetching data from OpenML. That particular API is bundled with the sklearn. Okay, so Arshid, that is the only question that you had from this practice assignment, or you have more?
Actually, it would be, can you just do these things also? Like it will require some coding.
Yes, this will require some coding.
So I have tried few, but I have questions in like the other next questions.
Okay.
Can you just scroll down?
Okay.
The next. Yeah, this one we actually have to solve this, but then I'm stuck here.
Okay. What
So
is
yeah, this shuffle this thing is done.
mhm.
So all these things we have to do it like we can say with some loops or manually, right? We have to code these things. Wherever the class is 9, we have to, wherever it is 6, we have to label it as 0, 1, and for 9 we have to do it -1, right?
Right,
Or by using
right.
some loops or something.
Not loops at all. Did you see if you remember? So I would suggest you to use np.where.
Okay, np.where. All right. Yes. Yeah.
And go through the collab that I had displayed earlier in this session. So you'll find the exact code how you could in one line of code you can give the names to, give the labels to 6 and 9 classes.
Okay, so I'll do that. Actually, did that. I did the labeling and all, but I couldn't do that 1 and -1. I collected the samples with 6, collected the samples with 9.
Okay.
But the last thing I couldn't do 1 and -1. So I'll see that Collab and I'll try to do it.
Okay, sure. Any further questions from practice assignment?
I think this.
That's it. Okay. So all of these yes.
I haven't yet solved.
Sorry, I did not get that part.
I think I mean, a lot of people haven't yet solved it, I feel.
Yes.
Okay, sure. So all of these practice questions, you will have to write a few lines of code to get the answers.
Sir, I just wanted to ask one thing. If you see the third question, I think the fourth question.
Fourth question is
okay.
This.
Here we have changed the labels to 1 and -1, right? Okay. What if we don't change it as 1 and -1 and we keep the label as 6 and 9 itself? So will the other values of weight vectors and all, they will be different or they will be still the same because there is still the classification problem?
Okay, so you have asked a very important question. I would suggest you to do this and experiment with it.
Yeah, I have done that only because I wasn't able to do 1 and -1. So I just continued with 6 and 9. But the numbers that we're getting, the next question that asks for weight vector, I guess. So I'm getting completely different numbers.
Yeah, so for this particular assignment, you are not going to get, if you just go with 6 and 9 labels, you are not going to get the correct answers.
Okay. But the classification will be done with the same accuracy and all, right? Weight vectors might be different.
So what accuracy? Did you get the same accuracy? Oh, you have not tried the second
I haven't completed it because I got the different weight vectors. I thought I'm doing something wrong.
Okay, so you are actually pointing to a very important concept in Perceptron. Try this and see. You'll learn something new.
I'll do it in both the ways, right? With 1 -1 and 6 and 9. All right.
Yeah, sure.
Okay. Thank you.
Sir, in exam we won't have the compiler.
What compiler?
There won't be such questions in the exam, right? Where we have
Why
to
will
code
not? Yeah, you will have to write the code. These kind of questions would be in your practical exam, not in theory.
No, yeah, that I know obviously about the proctored exams, but I'm asking about this.
In theory, you will not get questions like this. Yes.
So mostly in the theory, we have to focus on the names of the libraries and what special features and parameters they hold, like that, right?
Yes. So in quiz, the questions would be of MCQ type, MSQ type, and numerical answer type only.
No, but I'm saying we have to focus on most, like whatever libraries we have used, whatever hyperparameters and parameters we have tuned or we have used, and know the functions of them, right? Like for example, we have learned standard scalar. So what standard scalar does, what is the formula, and how to compute if someone asks about it, right?
Yes, yes, things like that, of course. So go through the mock exam; they are available.
Go through that I went through, but that, I was just confirming because because in the last semester for my MLF paper, I thought the paper pattern would be the paper questions would be a bit different, and the paper had some different things. So I just wanted to
Okay.
ask.
Okay, sure, sure. So yes, the things that you mentioned, application of those APIs if they are numerical and things like that. What are the internal workings of some of the APIs? If it's very important for you to know, those could come. The important parameters that you mentioned, they will also be there. So I would say anything which is being covered by sir in the lectures or anything which is covered by sir in collabs. I mean, even though I'm making distinction of collabs and slides, but both of them will be part of your syllabus from
So
which you can get questions.
the syllabi will mostly consist of whatever the APIs we have used and their parameters, right?
And
Not
the assignments, practical assignments also.
practical. We don't have practical assignments in. I mean, in MLP actually.
You have practical assignments, right? Graded and practice
we have
questions.
practical. We do code. We do code in, but like for example, we don't have a graded assignment, graded programming assignment as of now, right? If I'm not wrong.
You have graded programming assignment in every week of ML practices, if I'm right.
ML. I mean you mean yeah. I mean the specific grade in programming, like we don't have a special tab for it. We have to code to get the answers, but like that
Okay.
we don't have. Like in MLT we don't have isme abhi tak. If you get
Yeah. So I get your point. In ML techniques, you write the code inside the portal. In ML practices, you write code in your personal collab or your
in
machine
the
computer.
Collab or Jupyter notebook, whatever.
Yes, yes. Right. But what I'm saying is the quiz questions could be based on your experience in solving those programming problems.
Perfect. So basically, all the stuff covered in the lectures, because most of the programming, grade assignments consisted of whatever we have done in the lecture by Ashish sir. So like we didn't have to do much different things as of now, but yeah, like something like that only, right?
Yeah. So if you do that, Tanvir, I think you'll be in pretty good shape for your preparation.
Okay. Thank you so much, sir.
Okay. Okay. Any further questions?
I have one doubt in week 4, the last question of the graded assignment. Okay. Even we have put it in the forum also. Okay. If we are using the pipeline, okay, and in the pipeline we are putting the standard scalar, okay. The way the question is not asked to use the pipeline, but if you use the pipeline with the standard scalar, after that you are calling the lasso function, okay, and after you are putting this read search CV, and inside you are calling this pipe, okay, and then you the parameter, the values are coming different, okay.
Okay, that is interesting.
And but if you go follow the question, in that question what they are doing, that you do the standard scalar first, okay, get the training and test data, okay, after that create a lasso, then go and create a grid search CV, and then you pass only the lasso and their parameter, and when you are we are passing the standard scalar, that standard scalar X trend and Y trend, okay, not Y trend. And if you go and check the score and the alpha, that's a difference. Okay, I tried, but I'm not getting whether I am doing some mistake or its system is doing, because if it is using the pipeline or not using the pipeline, the underlying algorithm is same. So if you have the time, can you check that one?
Sure, Mukesh. So so have you posted this question on?
Yeah, it's already there in the discourse. Okay.
Okay. I'll take a look. I'll definitely take a look at this.
I'm trying to find what's the difference, why it is coming difference.
Sure,
Are you
Mukesh.
saying with pipeline and without pipeline, you're getting two different answers?
Yes.
That should not happen. Actually, you should get the same thing.
Yeah, I know. I have posted that one that time. What sir has given that solution, there the alpha values are different. Okay, so they have corrected it, and on that the way they have done it, it's coming 0.005 alpha value. Even your cost score value will come different. But one person has posted that in that he is using the pipeline with the standard scalar and lasso. And I tried that code also. I compare with my code. Nothing difference is there, but still the value is coming different.
Okay, I have pasted one code. You can try with that with the pipeline.
Yeah, you tried with the pipeline. Now what you do, you just take the scalar out. Okay, put the scalar, use this extend, make it another variable like extend underscore standard, and you pass this standard in the grid search area. You will find the difference. I cannot share my screen. Otherwise, I can show here itself. It's getting the difference is there.
I think if you're using pipeline, then you should put everything in the pipeline only. No?
The value should not come different because pipeline is using the same way and transfer. Then it is coming to next.
Have you rerun the data because maybe because of doing it using like transforming the data too many times you have transformed
No,
it.
I tried many times. I closed.
Yeah, but if you want, have you checked on different collab sheets? Maybe because of rerunning and running the data too many times, the data might have malfunctioned or something like that.
No. I have separate block where I am writing, and the person who has posted in this course, I taken that code also. Okay, I run the compare all the codes. Even I commented his code and I put it my one. Okay, and then the value changed.
I mean, for example, अगर आपने एक बार California data set you have used and you have used the pipeline, the data has already been transformed, right? And if you are using your personal code again, you are working on the transformed data set then. So maybe that's why the reason the error is more. Or
No, not like that. See, if I'm putting a California, I'm using the extend and white train. So he is using extend and white train directly in the pipeline. Okay, whereas we are transforming as per the program. You need to take the standard scalar, apply it, and that standard scalar X, we are passing it. That you just try it, you will get different. It's really surprising for me also. That's why I raised this topic.
So your standard scalar is not inside the pipeline, is it?
Yes, right.
Okay, so if your standard scalar is not inside the pipeline, so when you're finding the score, that time you have to pass the normalized test data.
Oh, sir, can you able to give me share access? I want to show it. Then maybe you can clear.
Sorry, Mukesh, I cannot do that. I would suggest you a different method to collaborate. Can you share the link of that post in the chat box to everyone so that people can take a look and help you?
Okay. 1 minute. Even Jimmy sir has also checked that part. Okay.
Okay.
And he also tell the value will come 0.005. Okay. And it is matching with my answer. Okay. But the person who has posted, what is his name? Shreyans. Okay. And his code is also correct. There is no problem in the code. But only different.
I see. So I think Shreya's answer, she is using a different scoring function.
There is no scoring function I can see.
Oh, Shreyansh. Okay, he is not using a different.
No, that's a different lady. That's Shreya. No.
Yeah. Okay. So
there is wrong. She should not use negative mean and all.
Right.
Shreyansh Badriya, right. Sorry if I'm pronouncing wrong.
Shreyansh Bardia. Okay.
Yeah, Bardia. Okay.
Sure, Mukesh. Let me take a look at that and I'll come back.
Please. Yeah. Okay. Thank you. Sir.
Okay. Tanveen and Arshad, you also take a look at this post.
Yes, sir. I'm looking at it. Yes.
Okay.
I think the one which is posted there, I think I have the same solution with pipeline. So I'll also check it. Okay.
So can we leave?
Yes. Is there does anyone have any further question? Okay, then thank you everyone. Happy Republic Day.
Thank you.
Enjoy your holiday. Thank you. Bye.